to get everyone else to sit down and shut up. To introduce our keynote speaker, Niek Veldhuis, who is a professor of Near Eastern Studies, who has the distinctly complicated task of not just analyzing text, but analyzing text that was written in Cuneiform. So if you think you've got problems. Right. So Niek is going to talk to us about representation of Sumerian text using FastText, which I haven't seen anyone use, so this will be really cool. And those are the symbols that mean something. He's going to tell us what it is. Okay.
Oh, it simply means representing Sumerian in FastText.
Seriously?
Something like that. Anyway, well, thank you for your introduction, Heather. I'm very pleased and also rather proud, I should say, as a hardcore humanist to be here at this TextXD conference. I'm going to talk today about Sumerian word embeddings. And because I suspect that the concept Sumerian, that you may be a little rusty around that, some of you, the outline of my talk is actually very simple. I will introduce Sumerian to you in a few words, and then I will talk about issues around representing Sumerian. In general, representing Sumerian for CTA, and more in particular in FastText. And I don't know how much I should introduce FastText, but we'll get to that later on. So about Sumerian. Sumerian was a living language in the 3rd millennium BCE in the deep south of what is now Iraq. It was written in Cuneiform, as you see here in the example text. It continued to be used, however, for a very long period, for about 2 millennia, from around 2000 to 0, as a language of scholarship and religion and literature. So some of the main genres that we have, for which we have Sumerian text, you find listed here. What I want to emphasize, however, is that by far the most important genre is the one that you see listed first, that is administrative text. So the great majority of the material in my models is administrative in nature. But we do have a broad variety of texts in Sumerian. Sumerian Digitalcorpora started relatively early, at least early to humanist standards. So the first important digital corpora that we have started in 1996, that is more than 20 years ago by now. They were active until 2006. This is the electronic text corpus of Sumerian literature at home in Oxford, and they cover about 400 literary compositions in Sumerian. My own project, the Digital Corpus of Cuneiform Lexical Text, which is based here at Berkeley, publishes digital editions of word lists. These are lists that were used in scribal schools. So that's the kind of stuff that you use when you want to learn how to read and write. And finally, by far the largest collection is EPSD2, that is the Electronic Pennsylvania Sumerian Dictionary. They actually do not edit text themselves, but they sort of harvest text from all possible electronic resources, bring them together, make sure that they all follow more or less the same conventions, lematize it, and then use that for creating dictionary entries. And I'm one of the co-editors of that dictionary. So all in all, right now I can harvest approximately 4.3 million tokens in Sumerian, and I've asked myself, is that a little or a lot? Can I see hands? Is that a little? Is it a lot? Oh well, I'm pleased with that. So but to tell you frankly, I still don't know. Because if you compare that, of course, to what people scrape from the web, in English it is still very, very little. I think for an ancient language it is actually a very decent corpus. I think I got myself a little bit in trouble in trying to make it as big as possible, because that means that I mixed all kinds of genres and all kinds of periods of Sumerian in one big bag, and maybe I shouldn't have done that. That may be something that I need to reconsider. So how then do we represent Sumerian for computational text analysis? There are essentially three main methods for doing that. The most traditional one, and the one that my colleagues will actually recognize, is, my colleagues in Sumerology, is in transliteration. Transliteration means that every sign is represented by something like Lugal or A. And signs are separated from each other either by a dash or by a space. A space here means, as we do in English, that there is a word division there. It's important to keep in mind that there is no word division in the original Sumerian. So that means that word division is one layer of interpretation that you bring into the transliteration. You can also see here, by the way, this sentence means the king built a temple. A very common sentence in royal inscriptions. There is a one-to-one mapping from a transliterated symbol to a cuneiform symbol. And that's why you have the index numbers. So there are multiple signs that can be transliterated as A. You see two of them here, Lugal A and A2. They look very differently, and they also have different functions. So what is transliterated here as A2 is a word sign that means house. What is transliterated here as a simple A is morphology. It indicates that the word Lugal, which means king, is the active element in this sentence, is the actor. A second way in which we can represent Sumerian is in lemmatization. So lemmatization consists of three elements. That is the citation form for your first word, that is Lugal. Then we get a very basic kind of translation. Lugal means king, and then we get a part of speech. That is very labor intensive to lemmatize text. So not all text has been lemmatized, but a lot of it actually has. What is important to realize is that what you get between the square brackets is technically not a translation. So you see that a second word here, which I translated as temple, is lemmatized here as house. And that is because the lemmatization simply refers you to an entry in the dictionary. That is what lemmatization is. It doesn't care about contextual sense of that word. Finally, we can also represent Sumerian in cuneiform. So the cuneiform here is produced from the transliteration. It is in Unicode, so it uses the Unicode code block for cuneiform. What it ignores is polyvalency. Every sign in Sumerian, or almost every sign in Sumerian, can be used for different things. So the sign mu, for instance, in the last word, in mu undu, can also be read muchaldim, where it means cook. Here mu is a grammatical element that indicates that this is an active verbal form. So when you transform transliteration into cuneiform, you lose that. You get the polyvalency back of those signs, which has advantages and disadvantages, as I will explain in a moment. So a bit more then about polyvalency and about transliteration conventions. What I just said about the sign mu, I could also have explained with the sign un. The sign un has three basic readings. That is where it means people. It can also be read kalam, where it means land. And then it can be read un with an n, where it is a morphological element. That is real polyvalency. That's polyvalency that is built into the cuneiform system, and it needs to be disambiguated. That may look complicated, but in practice it is usually very, very clear which reading you actually need from context. There is, however, also artificial polyvalency that is basically created by modern Sumerologists. So you see here the second word that I've listed here is sangdun, which is a word for recorder or measurer, land measurer is essentially what it means. And we are not entirely sure how to read those two signs, and so there are a number of different representations of that same word. And I've taken these representations from my actual data set, so these are not made up, but these are actually different representations of the same word that is the same in cuneiform and also the same in lemmatization, but not the same in transliteration. Did I explain that well? Yes? Okay. So that, of course, is really a problem of standardization. If you have this kind of noise in your data set, you do not really know what you are looking at. So, and there is a second problem with transliteration that I wanted to point out to you, and that is a problem with tokenization. So which signs belong together to make a single word? That is a surprisingly hard problem with Sumerian. With Akkadian, by the way, that is very easy. With Sumerian, it is very hard. And to explain that to you, I have the pleasure of explaining to you a little bit about Sumerian grammar. Sumerian does not use prepositions, it uses postpositions. And these postpositions do not come at the end of a word, but they come at the end of a noun phrase. So you see here in the bottom half of my slide, you see the element she, she3, which means towards. And so A2, she3 means towards the house. A babar she means towards the White House, not with capitals, but simply towards the White House. And a lugal e muundua she means towards the house that the king built. So that she element means towards, it also signals the end of the noun phrase. However, we do not have anything that signals for us what is the end of the noun. So that means if you look at the top of my slide, are we reading udu babar for a white sheep as a single noun phrase, as a single noun? Or do we split that into a noun and an adjective, sheep and white? Most scholars today would argue that these are two words. What about egal? Is egal palace, is that a single word? Or is it the word for house, a, and the word for big, gal? Here, in this case, most scholars would choose for the single word. Egal is a single word. These, frankly, are two very obvious cases. Egal is a word that is loaned into Akkadian as ekalu, which sort of indicates that it is a single word there. Also, the way that word functions in Sumerian seems to indicate it is a single word, but there are many, many boundary cases where it is not at all clear whether we have to combine elements into a single word or have to separate them as two distinct words. The only solution to that, I believe, is an authority list of Sumerian words. We're working on that. That is essentially the Pennsylvania Dictionary for Sumerian. So what I've done, the three ways in which we can represent Sumerian for computational text analysis, that is in cuneiform or in transliteration or in lemmatization, I've simply taken all three of them. And I've built three different models. So I've downloaded the data set and created three parallel corpora, one in transliteration, one in cuneiform, and one lemmatized. As you can see, there is a fallback option. So not every word has been lemmatized in the corpus. Names have very rarely been recognized. So the penultimate entry on your slide, you see an example of that. So if there is no lemmatization available, it falls back to transliteration. And the same actually happens in the cuneiform column. In this case, everything is transferred into cuneiform. But if that is not possible for one reason or another, it simply uses the transliteration there. And what I've done with that 4.346291 tokens is I have made FastText models with that. For those of you who are not familiar with FastText, FastText is essentially a derivative of Word2Vec, but what it adds is subword embeddings. That means that you can take a sequence of characters and make that into its own vector, which you add to the regular vector. So that helps in two ways. First, words that contain similar characters are very likely built up out of similar word parts, and so they share some meaning. That could be a morpheme, it can also be in a compound word. The second thing that FastText adds is that you can actually use out-of-vocabulary words, which is not possible in Word2Vec or other word embeddings. And you can do that because it can put together the out-of-vocabulary words from the subword vectors. So let's now test our FastText embeddings. And let's start with a sort of canonical test. Does it work? King minus man plus woman, is that going to be queen? Unfortunately, that does not work. Frankly, I have no idea what this is doing here. I really don't know. So how can we interpret it? By the way, if you do it in embedding, you get something different but equally strange. That doesn't mean anything either. I think what happens here is king is a very, very common word that you find all over the place, also in the administrative corpus, because king is a very frequent word in date formulas. Queen is much less used. There are certainly plenty of occurrences for the word for queen, but they tend to occur in very different contexts that have nothing to do with kings. For instance, you will find them in hymns to goddesses where they are called Queen of Heaven or something like that. So I think that's probably a reason why this doesn't work, and we should try more culturally appropriate questions. So let's see what happens. So what if we took a sheep and we add to that calf and we subtract a lamb? What should we have? What should we get? Sorry? There you go. Yes, that's what it does. So that is a bit more encouraging. We can do that same thing in the lemmatized model. And one of the surprises that I ran into is that the lemmatized model actually does exactly the same. It also gives you ox as the very first, most similar form. Not only the very first entry is the same, but actually the first three entries are the same. They are in slightly different order, but they are the same. And in transliteration, actually you again get that same word for ox out of it. Try a slightly different one. Oh, I'll give you a translation. What if we took grain? Bread is made out of grain, so we subtract bread from that and we see what is made out of gold. Let's look for that. So these are the top 4 entries. Not exactly what I would have expected, but still pretty good. So hush is a word that you can use for all kinds of things, for things that are red or furious or something like that. But it is certainly very common as an adjective for describing gold. And the same is true for seesaw. You can say seesaw of all kinds of things, things that are normal or regular or okay. And you can also use it for common quality gold. Ningestuk, that is a very nice one. A word for earring, yes, that is something you make out of gold. Abiza has nothing to do immediately with gold, because abiza is a chip of stone, but you use it in the same context where you use gold, namely for making elite objects. So that's nice. This again is very surprising to me, namely when you do this same thing in the lemmatized model, you get essentially the same result. So we get again sisa that we had in the other model too. We get gush again for reddish. We also get some satum, emblem. For those of you who speak Arabic or Hebrew, you may recognize that as the word for sun. So it is a sun disk that is an emblem for the sun god, which is a word that is in some ways culturally very similar to ningeshtuk, the word for earring, as something that you make out of precious material. Let's try something very different. What I've done here is, I don't think you can actually, well, you can sort of read it, right? Oh, that's not bad. Okay. Yeah, you may need a little bit of education, but you can read it. What I've done here, I have taken two words. One is shimgik, that is a type of wood that you use in perfume recipes, and the other is gisar, that is probably something like lettuce, anyway, a vegetable. And I've taken the 35 most similar words to that, and then projected those with TSNE on a two-dimensional plane. And one of the things that is very striking and interesting is that these two sets of 35 words are very well separated. They also make a lot of sense. All of the red dots are indeed words for vegetables. Most of the red dots are words for vegetables. Interestingly, there is also a group. Can you see my mouse? Mm-hmm. There is a group here where you get signs for fractions. So these are numbers, and all of them are fractions, like 2/3 and 1/3 and 1/6, which is a bit odd maybe, but interesting that they end up in the same area of the graph. The words that with the black dot are all ingredients for perfume recipes. We actually do not have such recipes. What we have are delivery accounts, and it says these are deliveries for making perfumes. And you get all of these words in there. So again, that is very, very satisfying to see that coming up in this way. We can do that same thing with our transliteration model, and we've lost the numbers now. They are not in this particular model. So they're not, the two models are not exactly the same, but they are still surprisingly similar. You see that they are similar in the way that they separate those two groups of words. You have to believe me if I say that they're also similar in that many of the same words are represented here. Something else that I found rather satisfying about this particular graph, not sure that I can find that right now, but there are a couple of words that have different spellings in Sumerian that you can write with different sequences of Sumerian characters, and they end up in the same area of the graph. So, yeah, now of course, oh, you can actually see that to the right. Maybe I can find it with my mouse. You find the words kamamtum here in two slightly different spellings, and they end up immediately next to each other. Now, there's also something that worries me, in particular about the cuneiform model. If you look at the cuneiform model, and I'm going back now to an experiment that I showed you earlier today, that is the grain and gold and bread one. These are the 10 most similar words that come out of that. And in content, they make good sense, I would say. What does not make a whole lot of sense to me are the numbers. To me, they are too high. Even the 10th word is still above 0.9 in cosine similarity. And that seems to be a trend. Whatever two words I put in, say, donkey and king, I get a similarity that is above 9. And that doesn't seem right to me. So they are still arranged in the correct way, but it seems that all words are somehow similar to each other. Now, I've thought quite a bit about that, why that could be the case, in particular in the Cuneiform model. And I think I have found the answer to why that is the case. And the answer is simply in the length of words in Cuneiform. As we've seen, the word for grain is simply a single character, the word for gold is 2 characters, and the word for bread is, again, a single character. Now, in FastText, that actually doesn't make a whole lot of sense, because FastText is going to look at subword vectors, and there are no subword vectors. So, my assumption, I do not understand the mathematics behind FastText well enough to really say that with a lot of confidence, but my assumption is that a large part of the vector space here is simply empty, and that all the words are sort of together in one particular part of the vector space. In other words, that for using FastText, actually the Cuneiform model doesn't make a whole lot of sense. About word length, I've tried to illustrate that with the histograms here. What you see here is that about half of our tokens have a character length of 1 in Cuneiform. If you look at the lemmatized model, the highest bar here is about 10 characters, 10 or 15, I believe. And if you do that for the transliteration model, you would get approximately the same graph for that. Okay, so where does that leave us? First of all, I think the Cuneiform model is much less useful than I had thought when I was building it. In particular in FastText, it is less useful than I had thought. It may be that FastText Cuneiform is still useful for analyzing names, because proper names tend to be brief sentences in Sumerian. That is names for persons, not names for cities. Names tend to be brief sentences, and so they are longer. They may have 4, 5, or 6 characters. Plus, in proper names, we are often much more uncertain about how the signs should actually be transliterated. So there is a lot more variation or a lot more inconsistency in transliteration. And that inconsistency is resolved when you return the transliteration back to Cuneiform. So there may still be some use for the Cuneiform model, primarily in analyzing names. To me, what was a really unexpected result of this is that the Cuneiform model, the transliteration model, and the lemmatized model are much more similar than I had expected. I do not have any numbers to put on that. That's something that I have to learn from one of you how to do that. But anecdotally, they seem very similar to me. And so that could mean that we may be able to actually align those 3 corpora, or those 3 models, and predict lemmatization from the Cuneiform or from the transliteration, and that would be a very, very cool thing to do. I'm coming to the end of my talk, and you may very well ask, well, what is all of this good for, right? And I'm afraid that I have to tell you that I haven't gotten to that yet. So I haven't found, I'm very early in this process of building these models and trying to see how well do they work. but I do have some ideas of what I want to do with it. So I'm working with Adam and with a couple of undergraduates here on a social network analysis project of a large group of 15,000 administrative texts. And one of the problems that we run into is how to disambiguate between namesakes. Now that's something that this model would actually be very, very useful for, because we could look at similar texts. If texts are built in a similar way, that if they talk about the same kind of goods, say they talk about lambs and sheep, but they do not talk about earrings, that could very well mean that we're indeed talking about the same persons. So the same bureau probably produces texts that are structured in the same way. And that is something that we could very well research with word embeddings or with adding word embeddings to get a signature for what a type of text is that a particular person produces. Well, thank you.
How many dimensions are in the word embeddings? Do you remember?
I have 100 dimensions right now. Is that, would you recommend to up that or lower that?
Well, I was wondering if, based on those really high cosine similarity scores, it did seem to me like, as you were suggesting, that a lot of the space might not be used, and that perhaps a smaller dimensionality of the embeddings might force it to spread out the vectors.
Yeah, that would be something to look at. Yeah. So.
Given the same problem, you mentioned, well, maybe throwing out the Cuneiform corpus, but how about just using word to vec on it instead of FastText? Since you identified, the fact that FastText looks within words, the character clusters is a problem. Yeah. Why not just use regular word to vec? Yeah,
I think that would actually, that's something that I should certainly try. I think that for the transliteration model, I have seen that FastText actually does help me because we've seen that these words that are spelled slightly different actually do end up in the same area of the space. I'm actually sort of thinking I should probably give up on the Cuneiform model and say that is probably not the most useful thing to do. Yeah.
Thank you.
All right.